The spectrum of an oil flame is an example for continuous emission spectrum. Kinetic energy, velocity, stopping potential depends on frequency. Next question. PQ and RS. PQ and RS are long parallel conductors. Long parallel conductors separated by a certain distance. ಎರಡು long parallel conductors ಇದೆ. PQRS, they are separated by a certain distance, what I call as D. M is the midpoint between them. M denotes the midpoint between them, where the net magnetic field M is B. So first, we will calculate the net magnetic field. In the first case, B will be equal to magnetic field due to PQ minus magnetic field due to RS. Why this negative sign? Just go back to your theory. Current is in the same direction. Then the magnetic field should be opposite to each other. Current flows in the same direction. Very clearly, magnetic field due to the conductors should be opposite. Now, therefore, they are long parallel conductors. So 4 mu naught divided by 4 pi d minus 2 mu naught divided by 4 pi d, which is 2 mu naught divided by 4 pi d. This is magnetic field in the first case. The second case is interesting. Now the current 2 amperes is switched off, which means magnetic field at the center is only due to this 1 ampere current. So B dash is mu naught into 2 into 1 divided by 4 pi d, which means B dash is nothing but B. So the answer is the fourth option, which is B. We take this as an assignment, a simple one. Equate the forces, electrostatic force and the weight. We arrive at the answer. Next one. A series resonant. Very important. Resonance. LCR circuit. Athwa RLC circuit. The voltage across R is 100 volts and the value of R is 1000 ohms. Potential voltage across R 100 volts. What is the value of resistance? 1000 ohms. The capacitance of the capacitor is 2 microfarads. Capacitance value ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ 2 microfarads. Angular frequency is 2 radian per second. Omega nu ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. Then what is the potential difference across the inductance coil? I have to calculate the potential difference, not the value of this inductor. A coil do inductance value ಕೇಳ್ತಿಲ್ಲ, potential difference ಕೇಳ್ತಿದ್ದಾರೆ. Please to understand, students, at resonance. ಯಾಕಂದ್ರೆ very clearly they have told series resonant LCR circuit. So at resonant, potential across the inductor is always equal to potential across the capacitor. I want this VL, potential across the inductor. This VL is, I can write this as I into XC. Potential is I into R. What is the opposition offered by the capacitor? Yen karadvi adana? It is nothing but capacitive reactance XC, or VL is I divided by XC is nothing but 1 by omega C, alva? If you remember, XC is nothing but 1 by omega C. Omega value gottu, I value kandidibeko, C is known. Now how will I calculate I? See, we know V is I into R, or I is V by R. What is the potential across the resistor? 100. Value of resistance 1000. So 0.1 ampere. Ellanu siktiga. Just substitute. So this is 0.1 divided by omega is 200 into 2 into 10 power minus 6. When you substitute, 250 volt will be the answer. A capacitor and an inductance coil are connected in separate AC circuits. ಒಂದು ಕೆಪಾಸಿಟರ್ ಮತ್ತೆ ಒಂದು ಇಂಡಕ್ಟರ್ ನ ಸೆಪರೇಟ್ AC ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ. With the bulb glowing in these circuits, bulb glows more brightly when the dielectric is introduced in the gap between the plates of a capacitor. Which means when you increase the dielectric, capacitance also increases. And capacitance means ability to store more charges. There are more charges in the system. The intensity is more, brightness is more. So the answer is B. A horizontal metal is carrying an electric current from north to south using uniform magnetic field. It is prevented from falling under gravity. Direction of this magnetic field should be towards west. How did I get this? It is from Fleming's left-hand rule. Fleming's right-hand rule. The direction has to be towards the west. Next one. Empty number of times I worked out. 2015, 17, 18. The same question. 7 by 16 into the plane of the paper. Now, an ideal choke. Please to remember, ಇದನ್ನೊಂದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. Choke is an inductor which works on the principle of self-inductance. There is an ideal choke which draws a current of 8 amperes. Choke which pulls a current of 8 amperes connected to an AC supply 100 volts 50 hertz. A choke na AC supply connect ಮಾಡಿದೀವಿ 100 volts 50 hertz. A pure resistor draws a current of 10 amperes when connected to the same source. Choke connect ಮಾಡಿದಾಗ 8 ಆಂಪಿಯರ್ ಕರೆಂಟ್ ಡ್ರಾ ಮಾಡ್ಕೊಳ್ತಿದೆ. ಬರೀ ಒಂದು ರೆಸಿಸ್ಟರ್ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಸೇಮ್ ಸೋರ್ಸ್ಗೆ 10 ಆಂಪಿಯರ್ ಕರೆಂಟ್ ಡ್ರಾ ಮಾಡುತ್ತೆ. The ideal choke and the resistor are connected in series and then connected to AC source of 150 volts 40 hertz. ಈಗ ಆ ಇಂಡಕ್ಟರ್ ಮತ್ತೆ ರೆಸಿಸ್ಟರ್ ನ ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿ ಈ ಒಂದು ಸೋರ್ಸ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. Current in the circuit becomes, first, what is the resistance of this resistor? We know R is V by I. It is connected to 100 volts, draws a current of 10 amperes, so 10 ohms resistance. So individual resistance ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. Now resistance is 10 ohms. ಹಾಗೆಲ್ಲಾದ್ರೂ ನಾನು ಆ ಚೋಕ್ ಇಂಡಕ್ಟರ್ದು ಇಂಡಕ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಿಬಹುದಾ? ಯಾವ ರೀತಿ ಕಂಡುಹಿಡಿಬಹುದು? ನಾವು XL is 2 pi FL. What is this XL now? XL will now be 100 by 8, which is 2 pi 50L. So L will be 1 by 8 Henry. So very clearly, since I have a pi, yes. So R is 10 ohms, L is 1 by 8 pi. Now calculate impedance of the circuit. Because the resistor and the inductor are connected in series, calculate the impedance. Finally, current will be V by Z, where this V now is 150 volts. And when you calculate, third option will be the answer. The spectrum of an oil flame is an example for continuous emission spectrum. According to Einstein's photoelectric equation, the graph of kinetic energy of the photon emitted from a metal versus frequency of the incident radiation gives a straight line. First, we'll frequency depend upon intensity of the radiation? Absolutely no. I will wipe out this. Kinetic energy, velocity, stopping potential depends on frequency. It is independent of intensity. What depends upon intensity? Photocurrent. So kinetic energy does not depend upon the intensity. Again here, doesn't depend upon the intensity. Depends on the nature of the material? No. It is same for all metals and independent of the intensity of incident radiation. Kinetic energy does not depend upon intensity. It depends only on the intensity, and the slope always gives h, which is Planck's constant. Yav riti baribodu? See, kinetic energy is equal to energy minus work function. Y is mx plus c. This energy is h nu. So here you get the slope as h, which is Planck's constant. Here 3/4 is the answer. Simple assertion. The next one. Nu1 is the frequency of series limit of Lyman series. Spectral lines frequency ge formula recall madana. Frequency is RC 1 by N1 square minus 1 by N2 square. First case, series limit of Lyman series. So nu1 is RC. Lyman series N1 is 1. So 1 minus N2 is infinity because series limit. So nu1 is RC. Nu2 frequency of first line of Lyman series. Nu2 is giving me frequency of first line of Lyman series. So nu2 is RC. Again Lyman series 1 minus 1/4. So nu2 is 3/4 RC. Nu3 frequency of series limit of Balmer series. So RC Balmer series 1/4 series limit. So this is 1/4 RC. So how do you relate them? Good. 1 minus 3/4 is 1/4. So nu1 minus nu2 is nu3. This is a graph of specific binding energy versus mass number. Fusion of two nuclei of mass number lying in the range 1 less than A less than 15 will release energy. No. Fusion is not possible here. No. Here, fusion of two nuclei of mass number, middle mass number, they release energy. So D is the option. Pick out the correct statement from the following. Plutonium is not suitable for fission reaction. Fission can happen with plutonium. For stable nucleus, specific binding energy is low? No. Energy release per unit mass of the reactant is less in the case of fusion? No. Packing fraction may be positive or negative. Now, activity is always equal to lambda n. Decay constant in terms of half-life 0.693 lambda by n. Now, how do we proceed with this? We are asked the ratio of S1 and S2, which is the half-life. So I write A1 by A2 is equal to N1 by T1 into T2 by N2, or A1 by A2 equals T2 by T1 into N1 by N2. So, when you substitute for the ratio of half-lives, the answer has to be 4:1. When a neutron is disintegrated to give a beta particle, we have a proton as well as an anti-neutrino. So the reaction yields a proton as well as an anti-neutrino. Forbidden energy gap is so much. So we know E is Hc by lambda. Lambda is Hc by E. The value of Hc is given 2400 electron volts. This is 0.72 electron volts. So the first option is the answer. This is an assignment for you all. Very simple, based on semiconductor physics, just concept based. In a given direction, the intensity is same problem is worked out in the previous session. Intensity is proportional to 1 by lambda to the power 4, or with respect to frequencies, frequency to the power 4. The logical operation here is very clearly an OR gate. So Y yields A plus B. So this is an OR gate. Now, the de Broglie wavelength of an electron in the ground state of hydrogen atom. I pull out Bohr's quantization principle, which told MVR is NH by 2 pi. I want de Broglie wavelength from this. H divided by MV is 2 pi R by N. This H divided by MV itself is called de Broglie wavelength, lambda 2 into 3.14 into ground state. So radius is 0.53 divided by N. So N is nothing but 1. So the answer is 3.33 angstroms. So students, we have discussed our session today on CET 2010 paper. Next, we come up with CET 2009 paper. Until then, thank you.